Let's use remix. The last exercise I gave, that's what I want to do here, and then you use it to um I don't know. I think it's just only two people that submitted, just Daniel and one other person. So, but just go through it. Uh, so, so I think
So I think
I told you guys to build, what do they call it? A voting contract. I think that's what I gave you guys. A voting contract. Oh, I'm not sharing my screen. Let me share my screen. Can you guys see my screen?
yes,
Okay. So I said you should create a
Yes.
voting. Okay. So let's create a new file called voting.soul. Voting.soul. I don't remember how does that, the PDF, this thing. I want to make sure so I don't type in. I think I need the Solidity bootcamp. Like, let me just uh let me just do it from scratch here. So from what I said, I created the default this thing. Or what I'll do is um this is what I'll do. I'll copy it like this. And I'll paste it on my mail. My draft. Okay. Oh. Okay. Oh my God. SPDX. I remember. No, this is vacuum. I think I just have to write it from scratch. So SPDX identifier, and let me write the pragma solidity. The version 0.8.4 8.8. What is an invalid solidity version? What versions are available? 8.8 points. Yeah, point 0 is available. Okay, let me just say point. Point 1.8. So, can you guys hear me?
Yeah. Yeah, yeah.
Okay. 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 So, in here, I said the title should be. Oh, I can't type all these things. Let me just. Allow eligible voters come in. Trying to format it. Add. Blah blah blah. Implement when these use modifiers. Implement add a function bonus. Okay. Oh. So these are the functionality that we have to implement in this contract. So it's just a voting contract. It's a voting contract. This is the title: decentralized voting. Implement a decentralized voting system with the following features: allow the contract owner to add a candidate, allow eligible voters to cast their votes, implement a registration system for voters, add a time limit for the voting period, prevent voters from voting multiple times, allow the contract owner to finalize the votes and announce the winner, implement event logs, blah blah blah, use modifiers validation, implement a function to check the current vote count, should reveal individual votes, add a function to return the winner after the voting. I don't know how many of us like did this. Can you guys hear me?
Yeah, yeah, I can hear you.
Yeah, so
I'm not sure.
you're not sure. Like I said, did you do it? I'm not saying whether you are sure of your whether you
Okay, yes, yes, yeah, I did, I did.
okay. Anybody else? Is Daniel the only one this call? Roger Uche, if you can hear me. Okay, I don't want to waste much time. Let me just I'll be doing it now. So just follow along. So yeah, allow contract owner to add candidates. What again? Allow contract owner to add candidates. Then allow eligible voters to cast their votes. That's votes. So what again? Implement a registration system for voters. So voters should be able to, the contract owner will be able to add candidates, and then users will be able to register voter, and also so let's just work on with these three functions first, with these three functionalities first. So the first thing, yeah, the first thing is for us to know, okay, what is the data structure here now for the voting? I know that okay, there will be candidates and there will be um there will be a voter, there will be a candidate, a normal candidate. You'll be able to add a candidate, and then um there will be a voter too. So and the candidate should have a name, and um the candidate is the person that they are voting for. You get, that's the candidates, and then the voter is the person voting for that candidate. So we know that okay, from here we need to have the data structure we use is struct, because struct you use it to put it's just like a model, a database. So we create a struct called candidates, and this struct is going to have, as a candidate you have a name, the type of the name will be string. Then it will also have a vote count. That's the number of votes, just number of votes, vote count, which is going to be a uint 256. That I explained before. Uint is unsigned integer. It can be negative. So then a struct for the voter, that's the person voting, and the voter should have what we should be tracking is things like is the voter registered, is registered, which is a boolean, I'll put the type later. As he voted, he or her voted. I think these are the normal structures I give. Then voted candidate ID. And you have the delegates, which is like the address. This is the address of the voter. So this, if you take a boolean, sorry, can you guys hear me? This is a boolean. This is a uint 356, and this is an address. So now you know that first of we have to keep a, what do I call it now? Well, we have to create a modifier, because here we said allow contract owner to add candidates. So let's create a modifier for that only a contract owner has access to. So we call it only owner. So if you are not an owner, it will require that the message.sender is equal to the owner. And we can define the owner here, or maybe here at the bottom here. Address owner. Message.owner is equal to the owner. And we can see something like only the owner can call this function. Then we just put this underscore underscore. I don't know if you guys can remember. Modifier only owner. What is the error? Modifier does not contain underscore. Is there an underscore? Or it's just one? Yeah, it's just one. Sorry. Yeah, so the next thing, so we have to create a constructor. For now, this owner is just an empty address. So for this modifier to work, this owner now, we have to make sure that the owner is the person that deployed the contract. So we create a constructor which is defined on the call of a contract immediately is being deployed. So we create a constructor which we say owner. The owner we define there is equal to what? Message.sender, the person that deployed the contract. Person that deployed the contract. So what is the next thing? Allow contract owner to add candidates. So now the next function that we are going to create is to add candidates. A function add add candidate. A public function, and it's going to be while the modifier only owner. So to add a candidate, we have to create an array of candidates. Yeah, we have to create an array of candidates. From here, we can just create it here. So we can say candidates. We already have a candidate struct. So this is an array of candidates. Which can be publicly accessible. I don't know. Do you guys understand what I'm doing? Are you following?
Yeah, I am following.
Okay. Okay. So this is the array of candidates. Now let me put everything together. So now in this function, we can call the candidates dot push the array method. Then you put the candidates will come in as an argument. So and from the candidate here, the we'll have the name. So it's going to be a name. Let me put underscore, which is a string. Then remember memory. I don't know if you guys remember, we have memory, we have core data. Memory, core data, and storage. So memory is not um, stored on the blockchain. So it's coming in as an argument. So you push the candidates. You push the candidate, which is not, it's going to be like this. The name is going to be underscore name, and then the vote counts because you're just adding the candidates. So initially the vote count is going to be 0 initially. Where is the error coming from? Expected is yep. So candidates dot push this. So and remember I said implement events to log important action. So we can decide to log this when the candidate have been added. We can decide to log it that and then emit it. So we can create what do they call it? We can create an event that signifies when the candidates have been created. So we can just say, let me comment, let me say events. So let me call it candidates added. Events candidates added uint 256 candidates candidates ID and the candidate's name. So after adding the candidate here, I can now emit the event. So I'll just say candidate added. So the name, the candidate name is going to be this. Now the candidate ID, for us to get the ID, we can use the length of the candidates array, candidate dot length minus one. The What is the error? Emit. Sorry, you have to emit it. So I don't know. For us to get the ID, the way we track the ID of the candidate is that we are going to the length. Length starts counting from zero. You get if an array contains 5 elements, uh, array dot length is going to return um like it's five, but it starts counting from zero. You get, so it stop at for us to know the index of that candidate. Let's say for the first candidate, the index is zero. You get, for the second candidate, the index is one. So that's what we're trying to do here. We're trying to get the index, and that's what is used as ID. That's why we're minusing one. Uh, then the next thing is allow eligible voters, add candidates, allow eligible voters to cast their votes, implement a registration system for voters. So we create a voting function and also a register vote function. So function register vote. Have you created a vote struct? Yeah, a voter struct. Register vote, which is going to be the address of the voter. Public. Now, to register vote, we also said that for voters, to register vote, it has to be the owner that will register the vote to, or let me call it register voter. That's the person. So it has to be the only owner too. Now we are going to require that voters let me see. For us to register a voter, we have to make sure that the voter is not a registered voter. So I'm coming on this. So we are tracking this. We have to make sure that the voter is not a registered voter. So, and then we have, since we are taking in the address of the voter, I think we have to track, we have to create like a mapping somehow, a mapping of the address to the voter. Like the voter address, we are mapping it to the voter. So we can create a mapping. Sorry, a mapping. In a mapping, I told this like a dictionary. So we create a mapping of the address to the voter, to the address of the voter to this voter struct is going to be public voters. So, sorry. So right here, we can now call that mapping register voter. So we require that the voters, and put it in 2 lines, the voters mapping, the voters, that's called the address of the voter that we're entering now, dots, you can see dots is registered. Want to make sure that the registered voter. So this now is the voter is registered. So we can see if we want to require that it is not, so we can negate it with this. It's not registered. So we can say we'll now return the error. User is already registered. Or let me call it voter, since we're dealing with votes here. Voter is already registered. And then since we're registering voter, so for us to register a voter, then we'll now update the voters this thing, the mapping. So we'll say voters, it's voters underscore voter dot is registered. Let me just copy this here. Dot is registered is equal to true, because by default is false. So this user is already a registered voter. Is equal to true. Then and we have to emit also that okay, a user has been a voter has been registered. So I have to create another event here called register events. Voter registered. The address of the voter. So from here, after I do that, we just emit that event. Emit voter registered. It should be an underscore. So this is voter. So we'll be able to register a voter. Now, from this thing, we also said, and it's only the owner that will be able to register a voter. Then What is the next thing? Allow voters to cast their votes. So we have to create a function that allows voters to cast their votes. So create a function called votes. So votes. And for you to vote, you need the candidate ID. So let me say U8256 underscore candidates ID is public. Yeah, is it? Add the time limit for voting period. Yeah. So here is another thing. To add a time limit. So we know that we have this global variable called block time dot stamp. I told you then we also have as we have message dot sender, message dot value, we have block time dot stamp. So we can create a modifier that the modifier is going to make sure that okay, the voting is open and also the voting is closed. So because we don't just want users to just come and then vote at any time. You get, we have to make sure that the voting is that open or closed. So right here we can, let me comment this as modifiers. Let me call it modifiers. So the next modifier can see voting open. You have to make sure that the voting is open, and then we require that block dot timestamp is greater if it's open, so that means greater or equal to the start time of the voting, and is also less than the end time of the voting period. So we have to create a variable here. We can create a variable which we'll call, this will be U8256 public. You can call it voting start. U8256 public voting ends. Am I doing this correct? Yeah. So you have to make sure that the block dot timestamp is greater than the voting start time. And we also want to make sure that the block dot timestamp is also less than the voting end. That's not making autocomplete voting end. If not, we can throw the error and say voting is not open. Put this underscore. Then I can create another modifier called voting closed. So you require that the block.timestamp close is greater than the voting end. And we don't need this. So the voting as if the voting is closed, that means the current time must be greater than the end of the of the voting period. If not, we say um, voting is still open. It's still open. Then we end voting closed. So from here now, for a candidate to vote, for you to vote, you need your candidate ID, and then we have to make sure that voting is still open. So now, what is the process like for you to vote? For you to vote, you have to make sure that you are a registered voter. You have to really make sure that you're a registered voter. So that means you have to make sure that the person calling this particular function is registered. Is registered, and the person is a voter. Then we have to also make sure that the person has not voted before, and we have to make sure that the person is voting for the right candidate, a candidate that exists. Uh, yeah, I think those are the things. You have to make sure that okay, you're voting for the right candidate. You have to also make sure that um, you're a registered voter, and also you've not registered before. Okay, we check the voter this thing. She is registered as voted. Uh, this is the voted candidate ID. So now to get the voter here now, we can see call the person. Maybe the person is the sender, and we can call the person from the voters. Is it from the voters? From the voters mapping. The mapping we have here, voters, which is an address mapped to a voter. So, and then this address is the message.sender. Can you get this? And now this sender here, the sender must be a voter of type, the structure must be voter. And then told you it can be in a storage. Now we want to make sure that okay, you're a registered voter. That's the first thing. So we have to make sure that sender dot is registered. If not, we'll say you are not registered. To vote. We want to also make sure that require that the candidate you are entering exists. So you have to make sure that the candidate number is less than the candidates, the array of candidates dot length dot candidate dot length. Candidate dot length. If not, we'll say invalid candidate ID. And then the last check is that we want to make sure that the candidate has not voted before. So we require that, sorry, the voter, that's the sender, sender dot has voted. So as voted is going to be true. So we want to make sure that he has not voted. So which is not to negate it. So if not, we're going to return you have already voted. Now, after doing this now, for you to vote, we have to update that, okay, the sender dot has voted. Okay, I think I copied it. Is equal to true. That's we update that sender, the person voting, and then the center dot voted candidate ID is equal to underscore candidate ID. Then the candidate ID. Then what are we tracking again? Then we want to know what want to also once you voted, after you updated the sender information, that's the voter, we have to also update the candidate. And for the candidates, we have the candidates, the vote count of that candidate. So for us to get that particular candidate now, from the array of candidates, we are getting this particular candidate by the ID. Then we are getting the vote count. And then we are updating it plus plus this thing. And what again? Then we can also have this here in under this thing. We can have the total votes. So we can say you in 256 want to get the total votes. Public total votes. And then we'll now update the total votes here. Here. I think that should be all here. Yeah, and yeah, another thing we should do here is that since we are emitting everywhere, so once a user has voted, we want to emit the event. So we can create an event which you can call what should we call it now? Let's see, vote. I don't want to call it vote now because there's already vote. event, maybe vote casted, something like that. Vote casted, and then we can take the address of the voter and also the candidate ID. Candidate ID. Or let me just, since it's not past tense, let me call it vote cast. So here we can now emit that event. So broadcast is going to be the message dot sender, the person calling this function, and this one is going to be underscore the candidate ID. So I don't know. Have you guys been following? Have you been following?
Yeah. Yes.
Uh, Maybe I'll just, because for now, maybe I'll just stop here because I want to quickly like meet up with a deadline tonight. So maybe it's just like go through it. I don't know. You understand what I've done to this point?
Yeah, I'm following you. Can you share
Okay.
like the code on the group?
Okay. 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 The thing is, you can actually just like rewatch the video or something because since I'm not done, it does not make sense that.
I can continue
Uh,
from where you stop.
okay. But I'm going to continue it tomorrow though. But no problem. I'll send it to the group.
Okay.
Yeah.
I want to ask
Thank-
you something.
Yeah.
I want to. I'm reading the lending contract, but
Okay.
I want to make. I'm making a function that will liquidate the sum position once their collaterals is equals to the money they borrow. Will I use a chain link automation?
Yeah. Chain link. You want to chain link automation. I think chain link has um they have chain link VRF, chain link um um that automation. What does
Aggregator
it do again? That that
for
automation
just for speaking,
what it does.
automating
Okay.
things.
Is it like to pick a random?
No,
There's one
that's
that you can
VRF.
use to generate random VRF abi. Yeah. So
Yeah,
the
VRF.
automation so the automation, how would it work like for your lending contract now?
For what I read is that it will be checking if your requirement, what you set for requirement have been met. Once it has been met, the chain link automation contract we call the function that is needed to be called so that
Okay.
it will be liquidated. But it is you that will set everything up, but it will be doing it
Hmm.
automatically.
Okay. Okay. Makes sense then. You can because I've not actually used chain link automation, but the one I've used was chain link price fits, like getting
Oh,
um
okay.
yeah. mm.
Do
So
you have any like
but
any sound project like is production rate like to give you experience or like as if you're having like a real world production something.
mm, thing is most projects here that are built, except maybe when I was writing for Celo, all those ones are like simple contracts, but standard production is not they are usually private. You get it's not like
Okay,
open. Yeah, it's not open.
okay. So you were writing for what? Who?
is okay. There's one I just finished building, and it's in Funk. Let me even show you since I'm sharing my screen. It's not in Solidity. It's in Funk.
Okay.
I don't know if you've heard of Funk. Is the smart contract language for Ton.
Okay, Funky.
Yeah, Funk C exactly. Mm, let's even look at it again. Yeah, this is it. Though it's for a client. This one is for a client actually. So this is in Funky, and Solidity is far better. This one is just is hard. I'll not even lie to you.
Oh, it's hard. Okay.
Yeah, it's looking like Rust somehow. So
Oh, I'm maybe after this, I'm planning to learn Rust.
uh, makes sense to Rust too is a very great language, but I've not had the time. So this is why I did this is because of a client. If not, I would not learn it function.
Okay, you don't even know it before.
No, I don't.
So you call the
I
person gave
just
you
yeah,
just dive
yeah,
into it.
yes,
Wow, that
yes,
makes sense.
exactly.
Okay. I'm just trying to like make different projects to add to my portfolio.
Yeah, makes sense. Makes sense. You can build a okay, since we are building a Dex, we build it this week. So, but I will not
Okay.
build everything. I'll just build a part of it, and then you guys are going to complete it so that you can add it to your portfolio.
Okay. Okay. You know,
Yeah.
for as a Solidity developer now. You know, some people like as a if they are building a this thing does not have front end, just only code. You know, like so you don't have any front end with it.
You
Is it
can
presentable like that?
since you have to write a front, you have to actually write a front end for it, but you can still write. One thing you can do is that you can write tests, even if you don't have front end. Yeah, you can write tests. Then you can maybe on the
Okay.
repo, the readme of the repo, you
Uh,
just put screenshots of the outputs of the where you're testing the smart contract functions and all. So
okay. Okay. I get you. I get you. Okay. Thank you.
it's yeah. Let me just send the document here that contains the what I've done so far. So you can forward it to the group.
Okay. Okay.
Yeah. So thank you for joining in. Thank you for joining in.
How can I see the okay the chart?
Yeah, yeah, yeah. Chat.
Okay, I've seen it.
Okay.
Are you still there?
Yeah, yeah, yeah. I'm here.
Save the file, and I think you can save the file on Remix and copy the link from the browser. I think someone else can access it again from that link. So we just open directly on Remix.
Okay, okay. I should just paste the remix.
On the save it, just save it like that on Remix and copy the browser
Okay,
link.
okay, okay. That's true. Okay, okay. I've updated it then. Just it's still in that document. So
Okay, okay, I'll check it now.
yeah.
Okay, good night.
Yeah, good night. Thank you.